Okay, these are the instructions for doing our Dune Buggy motion activity, which should take a couple of class periods at least. The first class period we will be doing data collection with the Dune Buggy. In the second class period we're going to do graphing and analysis. That may wrap over a little bit depending on how long the graphing takes. The first thing you're going to do is open your notebook or your spiral to the next pair of blank pages and label them 5 and 5A. The title is Dune Buggy Motion. The objective for today is to measure and graph the motion of a toy dune buggy. The first thing we're going to do is run it in a straight line down the floor or along the tables. As it goes, one person will walk alongside the car and put washers down to mark the location of the car at uniform intervals. The uniform intervals will be provided by somebody clapping or snapping or making some sort of regular sound that we can follow. They're then going to measure the distance with a meter stick and calculate the total distance traveled at each point in time along the route. So the first thing you're going to do is create a graph, or pardon me, a table that looks like this in the upper left-hand quadrant of your paper on page 5A. We're going to be doing the graphing on page 5. So 5A needs to have the table. There will be 4 of these, so you need to leave some room. A later slide, I'll show you a picture of what these look like, but this is where you'll be doing your data collection. In this case, we have a video which will show you how to do the data collection. In our groups, we had about 5 people per group, sometimes as many as 7, but the people in the group served as different served different positions. We had a driver who put down the dune buggy and also walked around to the other side to make sure that the dune buggy was recovered or did not fall off the table. We had a pacer who went along beside and marked it with washers. We had a counter who measured the distance, somebody who recorded the data, and somebody who did the calculations. We also had one person who did the clapping to mark the time intervals. We had about 15 minutes or so, and everybody tried to collect at least 4 runs of data, and everyone gets all of the data so that everybody can graph their own, do their own graphs, but they have group data collected. Good.
3, 2, 1, go.
That was better now.
Okay, that group, we recorded what they were doing. You can see that they set washers down at even intervals. The clapper counted down 3, 2, 1, go, and then the dune buggy started, the starting point washer, and then marked the position at regular intervals. So the next thing they did was they measured the position or the distance between each washer like this.
To the front or from the back of the washer to the back?
Well, we've been going from the front to the front.
Okay, either one you want to do,
Yep.
as long as it's consistent.
31. 39.5. 34. 34. 33.5. Did you get that?
Yeah.
Okay. I don't want another mix up of that again. 36.5.
Yeah.
Yes. 29. 32.
So as the person who was calling out the data called it out to the recorder wrote down the time and then recorded the change in distance. You can see I added some units up here that they should have and you should have on your data tables. The time was in claps or beats. The change in distance between each washer was 31, 39.5, 34, and so on. And then there's a total distance column, which the calculator came back and added up in this table right here. So there's one entry for each one. So the total distance after the first one is the same, 31. And then we started adding them up to get a total distance in the end right there. So your spiral should have a total of 4 sets of data. When you're finished, the first set of data came from the video that you just saw. There are 3 more sets of data, which I color-coded. You don't have to do that right now, but you will later. I didn't complete the last column. I'll leave that for you to do.